All right, well, here's your Unit 1 test review video. We'll start with good old number 1. So it says convert 200 degrees to radians. So we know we have two formulas, pi over 180 and 180 over pi. Now the rule that I taught was if you're trying to get rid of degrees, then that's what you need to have in the denominator. So we're going to multiply this guy times that guy. So 200 degrees, I'll just put that over 1, times pi radians over 180 degrees. Now technically, these degrees, if I wrote the term DEG, they would cancel. And now I just cross-reduce. So I see that, I'll start with 20. 20 goes into that 10 times. 20 goes into that 9 times. And then I swoosh, and I get 10 pi over 9 radians. And that would be option A. And something to think about, along the way we've talked about pi over 4 is 45. Pi over 3 is 60. Pi over 6 is 30. These so-called easy ones don't go evenly into 200. That's why we couldn't resort to these. We had to use this or this. Okay, now this says evaluate. Notice there are no decimals. That means you are not supposed to just plug this into your calculator. What you are supposed to do is spin your spinner 330 degrees. So remember, your spinner always starts here. Because it's a positive, that tells us we got to spin it up. And so we spin it up. See, there's 270. You got to keep track of that because that's going to tell you need to go 60 degrees further. And I've been begging you guys to be somewhat accurate with your drawing. So don't make this look 45. Make it look 60 because that's what it is. And then remember, to complete your triangle, you never, ever, 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 ever come back to the y-axis. You always, always, always go back to the x. So we know that little sliver's 30. We know that's 90 and 60. We don't have any dimensions. We go ahead and assign some values. The side opposite our 30 we're going to call 1. But we can see that it's down 1, so it has to be negative. And then we multiply that by the square root of 3, and that would give us the square root of 3. This is not negative because remember, it's a coordinate point. So we're going right square root of 3, down negative 1. And then, of course, our hypotenuse would be 2. And so what is sine? Sine is opposite over hypotenuse. Don't you dare forget so, ka, toa. That's huge. So we know sine is opposite over hypotenuse, which would be negative 1 over 2. And we look for it. And there it is. B. All right. Number 3. It says evaluate tangent. So what do we know tangent is? Opposite over adjacent, but we're getting ahead of ourselves. We've got to think, okay, what's pi over 6? Well, pi over 6 is right over here. It's 30 degrees, something we should commit to memory over time. So that's just a different way of saying 7 times 30 degrees. So we got to find tangent of 210 degrees. Again, no decimals. So we're not to just plug that in our calculator and let our calculator spit out some decimals. You're supposed to be working on your triangles. That's kind of the meat and potatoes that's at the heart of this initial section. Always start with our spinner here. We got to go up 210, keep track. So there's 180, which tells me I need to go 30 degrees farther. Don't make it look 45, make it look 30. That to me looks 30. So I'm going to label that 30. Always go back to your x. There's my negative 1. This time this is negative square root of 3 because it's opposite my 60. This is a positive 2. Remember, your hypotenuse, your spinner, is never, ever, ever negative. So what's tangent? Tangent is opposite. This is our reference angle because it's sandwiched between the spinner and the x-axis. Don't forget that. Opposite over adjacent, which just turns into 1 over the square root of 3. And in this class, you'll notice that pre-calculus, if it's a 30, 60, 90 or a 45, 45, 90, they're always, always, always going to get rid of the radical in the denominator. If it's not, then they seem to leave it. So it's just something we'll have to work through. So we get the square root of 3 over 3. which is letter C. Number 4. This is going to be one of those weird ones that we had to deal with. So evaluate cosine. That negative that's the first time we've seen it in this review. That means you start with your spinner, and that means we go down. Down how far? Well, pi over 2. Well, what's that? Well, if you haven't had this memorized yet, in fact, that should be kind of on my list of things to memorize if I haven't done so yet. But remember, it's just as simple as replacing pi with 180. What's 180 over 2? 90. So I have to go down 90. Now, we can't literally go 90, or else our brains aren't going to be able to calculate what's going on here. So I'm going to go just shy of 90 here. And then remember, to complete our imaginary triangle, we always go back to our x-axis, not our y-axis. So we're going to go like this. And see, by doing that, you can see that our adjacent side is going to be the one that's 0. Now, a couple other things happen. That's my opposite side. I know it's negative because it's down. And what do we say about our spinner? Our spinner is always positive, and that's our hypotenuse. So it's asking us to find cosine. What's cosine? Back up to here, adjacent over hypotenuse. Our adjacent side disappears, so that's 0. What's the length of our hypotenuse? Well, we could say it's 1, we could say it's 10, we could say it's 100. What's 0 over any number? That's just going to be 0. So it's going to be letter C. And on these, I mean, seriously, just go ahead and type it in your calculator. Go, cosine negative 90, enter. You better get 0. So I don't mind you guys checking your work when you're done, checking your answer when you're done. But you're supposed to show your work so that I understand that you know what you're talking about. All right, number 5. This says, let theta be an acute angle, less than 90, in a right triangle. So let's go ahead and get this going here. And it says where tangent of theta is 4/3. Well, what is tangent? Tangent by definition is opposite over adjacent. So what they're saying is, get yourself a right triangle, pick one of these. Now, our drawing might not be perfectly accurate, but label the opposite side as 4. That would be this guy. We know this is our hypotenuse because it just is. It's opposite our 90. So our adjacent side needs to be this guy, 3. And it says evaluate cosine. Well, what's cosine by definition? It's adjacent over hypotenuse. In other words, you better figure out what your hypotenuse is. Well, if you were listening back in the good old days of geometry, this is just a 3, 4, 5 family. Now, what if those families aren't stuck in your head? Then you're going to have to go a squared plus b squared equals c squared. 9 plus 16 is 25. You'll still get 5. See that? But it says find cosine. Now don't forget, this is your reference angle. That's a huge point to remember. So that means you got to concentrate here. Now you got to find the adjacent side to that angle, which would be this, and put it over your hypotenuse, which is this. So that'd be 3/5, letter C. Okay. Now, number 6 is going to mess with you a little bit. Okay, the graphing is one of the most confusing sections, I think, in all of pre-calc, both trimesters. But what we have to remember is this formula, well, general, I wouldn't call it a formula, but kind of is. All right, so it says which transformation was not performed on y equals sine of x. So little by little, we see that A equals 1/3. What is that in words? That means there was a vertical shrink by 1/3. Now, whenever you say shrink, you can also say 3. This student is thinking multiplication by 1/3. This student is thinking division by 3. It's the same thing. But notice vertical shrink by 1/3 is right here. And this says which transformation was not performed. So we can eliminate that as one of our choices. Now we're trying to figure out what else is true. And so they don't talk about the period at all, so that means I'm going to skip this because the period formula is this. It's 2 pi all over the absolute value of b. So I would go, all right, 2 pi all over 2, which is pi. So, okay, yeah, I guess it does discuss it. So sorry about that. I'm glad I just pushed ahead there. So, see, our period is normal. Our normal period of sine is 2 pi. We talked about that a lot. Now, that's the time it takes the function. See, this is pi over 2. This is pi, negative pi over 2, negative pi. And the way we did it in class, the amplitude is 1. So it goes up to 1 and comes back to pi. And then it goes down to negative 1 and back to pi. You see, that's one period of our normal sine function. And this one is saying, okay, because that's 2, it is the new period is pi. That means it's going to be horizontally, here it comes, shrunk by a factor of, here we go, 1/2 or 2. You see, it went from 2 pi to pi. How do you get from 2 pi to pi? Well, it's right here. We cut the original period in half. So this is how you say it fancy. Horizontally shrunk by a factor of 1/2 or 2. So we look for it. Horizontal shrink factor of 1/2. Now this says vertical stretch by a factor of 3. And see, we've already said it was vertically shrunk by a factor of 1/3. So we could just say, you know what, this is what doesn't happen, and we could be done. However, we haven't really investigated this, so let's go ahead and investigate it. It says horizontal shift right pi over 4. This must be true because this is the only one that's not true. So let's investigate this. Remember, when we talk about a horizontal shift, I'm going to make this a little messy. We're talking about C over B. Now, one thing we know in class is that minus means we're going to shift it to the right. A positive would mean left. A negative always means right. And you see how it says right? And then it says pi over 4. How come it doesn't say pi over 2? Because you have a B that's something other than 1. So we have to use this formula and just say, all right, pi over 2, that's my C. See, that's right in the position of C, over B, which is in this position of 2. Now, what we talked about in class is in this situation, that 2 can jump over the line there, and then the multiply, so you get pi over 4. And so we say, to the right, pi over 4. That's why this is true, and that's why it's not one of our answers. And that's a lot of information on that one problem. All right. Let's see if we can get number 7 in before this 15-minute limit cuts me off. So this problem says, you got to look at this window first. This is what you should look at first. And I know it's hard because it comes at the end of your sentence, but it's something you just got to get used to. And so this is telling you, hey, only consider a spin greater than 270, less than 360. Well, here's my 270, here's my 360. So that means I can spin my spinner all the way around here, and it has to land somewhere in here. So not here, not here, not here. That's clue number 1. Clue number 2. This square root of 2, hopefully by now you are learning that that is screaming out that it's 99.999% likely it's going to be a 45, 45, 90. Also, where's that negative go? Well, we know that sine is opposite over hypotenuse. We also know the hypotenuse is never negative. So that negative must go with the square root of 2. So it's negative square root of 2 over 2. So we take all of our hunches and we say, okay, here's my reference angle, which should be x, but it can be x or theta. My opposite is negative square root of 2. It means my hypotenuse is 2, which would mean this is also a positive square root of 2. And we can check it. I'm going to have to continue in a second. I'm about to run out of time. Sorry about that.